session that will hopefully provide some answers to probably the most burning Swift developer question of this year. Or that's maybe just my impression. I gathered some notable quotes I bookmarked on my Mastodon timeline. This year, when I noticed that their number was increasing quite a lot over the previous years, you may have lost track, but concurrency is about 3 years old now, having been introduced in iOS 15. And like in every engineering field out there, you can avoid or ignore technology changes for some time, but likely not forever. These are thoughts and, frankly, doubts I had myself as I was eyeing the inevitable moment when I will have to deal this with all my ongoing client projects. And I really appreciate so many developers sharing their thinking because they were very beneficial to my own deliberation and eventual action. And I am far from what you would call a concurrency expert. I am an application developer first and user experience specialist, and iOS and Swift and SDK, these are simply my current tools of trade. I like those tools very much, and I tend to keep myself fluent or at least acquainted with new technologies in my line of work. So, never being ever optimistic about when it comes to coding, the only way forward is to try. So let me take you a year back, a little over a year back, to September 23, when our app was pretty much in perfect shape to even attempt this transition. The project was actively developed for almost a decade, during which we went through several transitions, pretty large one. Like the original application was 100% Objective-C. Then we switched to Swift 4. Then we also switched from tables to custom collection views, then compositional layout. And this is important I mention this because I assumed there was no possibility for surprises. We wrote every single line of this code multiple times. So let's enable complete strict concurrency checking flag, and let's see what's going to happen. You know how people describe scrolling to Twitter timeline like doom scrolling? This is dreadful, like dreadful, especially when it gets to the end. And you see over 5,000 warnings, all eyeing to become 5,000 plus errors in Swift 6 language mode. Brilliant. To say I was overwhelmed was very mildly speaking. And at the time, I did not have access to this amazing session from lessdub.dc with a very important message, not just for me, but for all of us. You see, when Swift concurrency was first presented to us 3 years ago, I assumed my work would be take all my closure-based code and convert it into async await. Do try catch errors, that should be it, right? Absolutely not. Not at all. Your main task will be solving a lot of this stuff. You have to rethink how you design your model types. You have to know to look very closely when you're calling self or self.whatever inside across threads and queues. When you use static var instead of static let. Sometimes even static let will not help you because it shares mutable state across threads. So all of this applies equally to closures and async await. It doesn't care which pattern you're using. And here's another message for that same talk. I mean, I love Ben Cohen, it's amazing. As long as you keep your project in Swift 5 language mode, none of this is showstopper for your work. You can attempt this anytime you want, see what's easy to fix, then turn the toggle back to minimal, clean build, and continue day-to-day to work. Come back when you have more time to deal with this. It's not mandatory, it's not urgent, you have time. So that's really fantastic. Okay, so first order of business is let's get some easy wins and get against this monster with 5,000 heads. If you look closely, there's a bunch of repeated lines, repeated warnings. And why they happen is we are using compositional layout, which is with different data sources. And the source of all of these errors, repeated stuff, is that our rather complex grid item model is not sendable. These are all Swift value types. So it was fairly easy to transfer this to be sendable. And then all those errors disappear. Here's another typical example. main actor property is accessed from non-isolated context. Main actor isolated property. When you click on this code, it looks like kindergarten painting class. Like every single line in a warning and an error. Like what the hell? So why is this happening? Every screen in our app is a pair of data source and UI view controller. And data sources are basically view model for the entire UI view controller. In this case, it deals with the compositional layout. And reason for this is that we didn't add main actor to this particular type, even though it's almost exclusively working with UIKit app, which are all main actor isolated. So just adding this cleared up all the warnings. Now, when you have like 100 screens in your app, this can easily add up, and in like what spent like 20, 25 minutes to add main actor to all data sources, we cleared out over 1,000 warnings. So that was super encouraging. However, inevitably, when you like add main actor to this, there are some pieces of code that is accessing like background queues, like data fetching, data processing, data sourcing, things like that. So you will get some new warnings back, but you're still making progress. You make like 3 or 4, remove 3 or 4 errors, and then you get one back. That's still progress. Eventually, though, you will run out of easy wins. And you will be left with warnings or errors which are neither easy nor quick to solve. Some of those stuff you may not even realize, understand why they are happening. Like that's perfectly normal. It's new stuff. And that is really unnerving for me because you feel stuck and you're not making significant progress anymore. And at this point, this becomes a logistical struggle between ongoing client work, like new features, new development, and maintenance work on concurrency instance. I can't say my clients, like, give me 2 or 3 months so I can fill this out. Like, that doesn't happen in agency work, like, never. So what I needed to do is somehow narrow down the target area. And that, in Swift terms, means modularize your app. You see, apart from third-party dependencies, entire app that we have was technically one module, 80,000 plus lines of code. But it was semantically comprised of many fairly independent segments. Each backend has its own service folder with its own types. Each middleware object has clear input and outputs. Each middleware object, like account, payment, everything, has their own errors and their own types. There were several pure utilities, like logger stuff. They could be extracted away very easily. And this was not by accident. This is the concept on the architecture approach we were using for our apps, like for the last 7 or 8 years. It's a slide from an old conference talk in the long-forgotten era pre-pandemic. Architecture has evolved a bit, but the basic principles still hold well. And they are, each layer should do as minimum work as possible, erring on the side of creating more layers instead of one clever do-it-all layer. And each specific flow through any of the layers should have one input and one output point. So what this allowed us to do is to create many packages with very small public interfaces. So this is what's happened after the modularization. So which crucially means less interoperability points between the models, so less places where we need to employ sendable to move between them. This was done carefully and slowly over a few months. As we were adding new features, which were immediately done in a packaged way. So this is the moment when actually I could start working on what I envisioned to do, and that is removing closure-based and going to async and await. And so this is honestly the most important part of this talk. Like, it has nothing to do with concurrency. Like, before doing any large refactoring, modularize your app as much as you can. It will help you immensely with concurrency transition, but even if you give up for a time, you will still have much nicer looking and nicer maintainable app than you had before. You simply double click on the package.swift, and you get a much nicer, a much smaller subset of your code, which is self-contained. You can compile it and hunt for errors. So if you don't give up on concurrency, you can enable very easy experimental feature flag. And then when you compile, you're seeing only 14 errors instead of 1,400. And that is much easier to handle. And when you resolve each of these, it's likely a lesson learned that you can apply to next package. So it's it adds up and you get faster over time. So first lesson is hopefully something that you did while hunting for the easy wins, and that is sprinkle sendable of any model type you have in the app, like every single one, even if you don't think it needs to be. This will compile a command, they'll tell you why those model types cannot be sendable, and it's an opportunity to rethink, like, why the hell am I doing this? Like, what is happening here? And you might be tempted to just do unchecked sendable, a problem solved. But don't do that. First thing is that it happens like with 20 or so very complex types that we have, that after doing some more fixes along the way, these types became possible to be sendable. So just doing something else clears the path for sendable. And in the end, if there is no other way, just add that check sendable and then wait like 6 months and try again. Like, it's not a problem. And second, never use actor for model types. Absolutely never. I feel very strongly about this. Model instances should be available from any thread without any delay. And when you do actor isolated properties are always awaited. I lost count how many types we have in the app, probably by close to 200. None of them is an actor, and it never has to be. What actor is, for me personally, semantically speaking, it's a class with private serial queue. So if I already have a class that does something like this, like internally locking something to prevent concurrent access, then I converted them into actor, and that worked out nicely. Code became more readable because I removed a bunch of boilerplate. Any example for that is, let's say, authentication model which needs to manage access tokens. You need to have only one thread writing into that specific property. Also, if you have a data flow that calls one method, calls another, calls the next one, if any of those methods is async, make all of them async. There is no benefit to get if you like switching from non-structured to structured like world. Usually in our application, that was like you click on a button and it starts series of calls to fetch some data. So just keep everything async, and remember, task is unstructured concurrency, so you can control its moment of execution, and you want to have less of them. Okay, this was all fun and games. It took us about 2 months to clear out 90% of those initial set of warnings. And then it took us 5 months to clear the remaining 10%. Natural question, why? And here's a perfect post I saw on Mastodon by Miguel de Icaza. Every single point that he writes here, we experience multiple times, every single one. And I'm going to give you examples illustrating those points, starting with a very fun one illustrating the second bullet point, trying to speed run fixes and to like speed run the transition. Our apps has on-the-fly translations. If you click a button, choose a language, everything instantly translated without restarting the app. And this was done by on upload, we load the translation dictionary from the backend, and you have a basically carbon copy of NS localized string that actually consults our dictionary, and everything is fine. And this was working great, while the app was a monolith. When we split into 20 packages, now those packages could not access this dictionary at all. So let's do some dirty quick fixes. And I create an open closure that has the same signature as my main function, and then instantiated every service from the packages. I just sneak in the shared function from the main app module. And you can just imagine how concurrency-aware compiler was happy about this willy-nilly sharing of mutable state across modules. So the proper solution took me more time than I care to admit, and it's actually very simple. Translations are fetched in the main app and saved into a local file, and then we create translation package which just reads that file and exposes the public localized string method, which is then added as dependency to every package that needs it and to the main app. No concurrency issues, no trouble, super quick, works very fast. There's some nightmare stuff. Like, I'm writing closures like for almost a decade. And whenever I see curly braces fix self, I automatically, without thinking, writing article itself, like immediately. And then I write my own actual code that I want to write. And in this case, we are making a delay of 5 seconds and then re-enable some buttons so we prevent customers to like manically clicking on some button. And if during those 5 seconds, the customer moves away from the screen, the app crashes. Obviously. Why? Because I got led too early. You need to switch the order. You need to first wait 5 seconds. And then, if self is still there, execute the method you want. Here's another one. When you're updating UI and you need some awaited data, never mix these two operations. Wait everything that you need, and then do updating in one single line of sequence of synchronous code. Here's an example. Whenever we get a betting ticket in the app, we need to, like those bottom string lines are summary items. They sometimes change, they sometimes like added or removed. So the simplest code for us would be simply to clear the stack view and repopulate it each time. But when we moved to await the data, funny things started to happen. Sometimes, not always, those items would disappear and reappear again, like they were blinking. Can you see what's happening? I remove all the items and then I'll await data. What's happening is that the remove was done in one render cycle and then await added enough delay so the reinsertion happens on the next render cycle, so you get blinking. Horrible. Again, solution, just reorder all lines. Like wait everything and then do one synchronous code. No trouble. Here's even more fun one. And I'm showing a screenshot because I was able to catch this in the debugger after like 50 tries. What's happening here is that we have a super complex screen with multiple data sources updating the display. And when customer changes the range of like matches they wants to see at the proper time, we need to refetch everything from the backend. So we toggle a bunch of local state and then do task to go into a data source and fetch the data. So what happens here, just a mere task is enough that while task is awaiting to be executed, some other data source will fetch this back to false, and no fetching happens. We get empty screen or stale data. Again, move everything into task, and if you're paying attention, data wait is still possibility for some other parts of this screen to again turn this off. But in practice, this did not happen yet, so we're just leaving it be, and we'll deal with that later. Okay. You need to understand that every single await you add is a possibility to introduce data races in your code that you possibly maybe didn't have before. Like every single one. Await doesn't mean, hey, everybody stop what you're doing, I need to get some data to continue my work. Await is more like, I'm going to chill in the corner for a bit, and you do whatever you do. Like those two are fundamentally different scenarios, different concepts. And both await and try await even more are very dangerous. Here's a piece of code that used to be like, I think four screens of closures, calling closures, like it was really terrible. It's basically all the stuff that needs to happen after customer logs in. And if you look closely, this looks very neat, very readable. I was very happy when I wrote this. It's also the most horrible piece of code I wrote this year. absolutely disastrous. And I'm going to explain why. If any of those tries actually throws an error, for instance, the second one, fetch active promotion throws 404, nothing after it gets called, nothing is executed. That's a horrible business mistake that could have legal repercussions for my client because we are checking player limits, which are legal obligation in some markets. So natural good solution for this is to basically do try await for each one separately. And then if anything fails, you will log it, but everything else continues to work. So these are all obvious errors in hindsight. I know, like, I will never write this again. But muscle memory for like years of coding in a different pattern is what made them possible. Trying to speed run fixes in the convention also what's made them possible. It's like, don't rush. Like, that's really important. Lastly, there was some stuff which are not my fault. Simply the tools were not ready. For instance, here are some stuff that we got as warnings, which makes no sense at all. Nothing we could do would fix them, and simply updating to next version of compiler removed some of them, and by 6.0, everything was gone. We didn't do anything. So basically, not even the compiler is ready for everything that iOS SDK contains. Like it's millions of lines of code. So it's September 2024 now. And we had every one of those 5,000 errors warnings removed. Like, we have 0 warnings. Code was fully transitioned to async await, and I was very eager to turn this particular flag from 5 to 6. But Xcode 16, let's try another clean build run in Swift 5 mode, hoping to get 0 errors. I got 700 errors of this time. Like, what the hell? Like, I'm gonna like place a code so it's easier to see. I am writing UIKit for over a decade. I know everything there is to know about UIKit. I had no idea that awake from if does not belong anywhere to UIKit. It's actually a method on the NS object. And NS object is certainly not main actor bound. So the error that compiler is telling me is perfectly fine. We use Xip for all our UIKit components, and we need to like clear out all the testing and design data when we when instantiate the component. So here is how that is solved. Thank you, Mr. Mazikot. I love this guy immensely. This is example of telling the compiler, like, I know you are correct, but don't worry, everything will be fine. Like, that's the 4th point from the Miguel de Icaza post that says he wants to like be able to do this. This is one example. Like, assume this is isolated, everything is fine, just go on. Okay, then. This was the last troubleshooting like point. And now it's time to answer, like, was it really worth all the effort? Like, we spent over a year on this. Like, that was no small thing for a small agency like ours. Like, we are 2 people. So what's the benefit we got? Like, this, first of all, like I said, provided enough incentive to do modularization now. Like, this was a long-standing to-do item. We'll do it when we can. Like, that time never comes until something kicks you in the butt. Thank you, concurrency transition. This is what I needed because now my app is much better. It also made the code way more readable. We were able to, when you look at, like, instead of a closure which is this big, you look at like 3 or 4 lines of code. We are able to recognize patterns which were repeated all over the app and to extract them into making the less lines than we have before. I always love deleting code, so that's perfect. And after we got all the troubles about await and try await and all of that, it made the app more stable. And I'm gonna illustrate, like, first 2 things are easy to like see. You just compare 2 screens of code and you see the difference. Like, that's easy. These 2 are really hard to visualize. So the only way I found it as like a proof is the bane of my agency is existing for like last 12 years. This is the crash report with 0 lines of my code, 0 actionable points. I have no idea what actually caused this. something somewhere in my code creates a situation that after some time, like 0.3 seconds or whatever, Apple code crashes. And I don't know how to fix this. I was just tolerating this constantly. So here's the kicker. We started publishing builds with this transition, like concurrency-enabled code in mid-September. And our app is not one app, it's actually 14 apps in 3 continents over like 20 or so markets. And since then, like 45 days, I think to now, hundreds of thousands of user sessions in all of those apps combined. Not one of these crash reports. We still have crashes, don't worry. But none of this type. Like, we know why they happened. I see the line of code that caused it. So it's kind of unsettling for me that I don't know what fixed this, but it's thousands and thousands of changes. But I don't care. No more crashes. So I have a reasonable hope that in like 2 or 3 months, I can clear out every possible crash from my app. So I'm going to finish with a slide that I saw like a week ago, which is from Alejandro Martinez. Like, nobody is forcing you to do this now. You have time. You can do it in your own pace. And if you find some like really problematic piece of code that's actually impossible to compile under Swift 6 language mode, extract it into a model and leave it as Swift 5 language mode. Fine. Maybe in 2 years, some scoop, like Swift C70 or Swift 8.0 will solve this on its own. Like, you don't have to rush this to fix everything that's there. So, thank you. I hope this was encouraging enough. I hope we have time for questions.
Yes, we do. There is one right there, Miko.
Hi, thanks for the talk. I'm kind of shocked by the fact that the code kept crashing in the example with the weak self capture. Okay. Have you looked into it? Why does it happen? Because when you do guard-let self, I thought you are increasing the strong retain count, and why it's getting deallocated?
It's getting I think it's getting deallocated depending on what else is keeping that code alive. I had the same question that you have. Like, if inside the task, if I guard-let it, it should be stay alive. But sometimes it happened, and then sometimes it didn't. Like, I can't explain why that was the case. Like, I'm not sure. Honestly, not sure. My QA testers love me for this. Like, it was really fun.
So, have you probably tried filing a bug report to Swift? Because it shouldn't. I don't think it should happen.
Well, that was like something around Swift 5.8. No, 5.9 when we started the transition. So right now, if I can try repeating it, maybe it wouldn't happen now because the tools are more advanced, like 2 versions more. So I really can't tell. I did report some stuff I found on Mastodon, and I found particularly Holly Borla for the Swift team to be very responsive to that kind of feedback. And even like one of the things I reported was fixed in 6.0. So maybe this was one of them. Like, but in 5.9, I remember very clearly this crashing. Like, I don't know why.
Thanks.
Cool. Do we have more questions? Structured questions? Not concurrent, hopefully.
No.
Yes, we have them down there.
Hi, hello. Thank you for your effort on Swift concurrency. Please, have you some examples about combine or reactive programming with concurrency? Because I know that combine does not support Swift concurrency at the moment.
Unfortunately, like maybe fortunately for me, but I don't use any combine in my app. Like I never used it, so I'm aware of reports that they are really not happy with one another. But I never personally used it, so I can't like really help you there. Sorry.
Yes, I think that was it. Thank you very much, Alec.
Thanks.